What is the V path correction on a dual crystal transducer, and does it really matter? Check it out. When you're doing thickness testing, you want the sound to go straight down and straight back up again. That's what you're interested in. But when you use a dual crystal, you're not really going in straight, you're going in at a V. So when you plug the probe into something like an MG2 or maybe a 38DL Plus, and it auto-recognizes it, it fixes everything for you. It knows the V path correction, and it knows actually the angle that the elements are set at. We call that the roof angle, because I think if you join them together, it would kind of look like the roof of a house. I've got another D790 probe plugged into my Sonotest Wave. I'm going to put it down on the 0.1 inch end of a stainless steel wedge. You can see I do see the first echo, but it's not really until the third that it maximizes. This is an artifact of firing from one side and receiving on the other, but that's not really what we mean when we say V-path. What we're talking about is an error in the measurement distance, and let me show you what I mean. Here I'll show you a regular dual element transducer measuring something really thin. And when that happens, you end up with a really wide triangle. So we're clearly not going straight up and straight back down again. We've got lots of error now because we got to go at a really big angle. And in order to correct for this, we do something called V-path correction, and that's built into our thickness gauge. Let me show you the practical effect of a V-path error. Here I took a very small dual element transducer and I actually calibrated it on the 0.1 and 0.5 ends of a step wedge. Now, you wouldn't typically use a transducer that small to measure a range that big, but let's say that's the way you set it up. This is a really good way to illustrate V-path error. My calibration points are at the 0.1 inch and 0.5 inch ends of the step wedge. You can see here, they line up perfectly, of course, because that's where I calibrated. It's the stuff in the middle that gets thrown out by a V-path error. Then I took readings at every intermediate step on the wedge, and you can see here that at an actual thickness of 0.2 of an inch, the machine reads 0.15 due to the V-path. The V-path error is proportional to the roof angle, but it's really difficult to try to find what the roof angle is of your probe. The dead giveaway is how tall is it? A D790 is pretty tall, so it's got a pretty low roof angle and very little V-path error. Once you get to smaller probes, you end up with more of a tilt, more of a roof angle between the transmit and receive sides, and then you get a lot more V-path error. Do we really have to worry about V-path error? Well, if you're using a D790, probably not. I'll show you an example here. We'll put it on the 0.1 inch end of the wedge. You can see gate 1 edge reads 102. I'm okay with that. We'll put it on the 0.5 inch end. We'll move gate 2 over there. I get 499. I'm okay with that too. Let's go to 400 and I get 400. We'll move to 300 and I get 300 and 200 and I get 200. So you can see a D790, nice and tall, low roof angle, pretty much no V-path error. To avoid V-path error altogether, or at least to minimize it, the trick is to just pick good calibration points. If you're measuring something that's 1/4 of an inch thick, don't calibrate thin on the 0.1 inch and then go all the way to the 0.5 inch, because you're never going to see 0.5 in your inspection anyways. The piece you're inspecting maxes out at 1/4 inch. So go from the 0.1 to the 0.3. This is more important with the smaller transducers that have the higher roof angles. V-path error is not really a problem if you've got a thickness gauge like that. You plug the probe in, it knows what's going on, it'll fix everything for you. If you don't, and you're doing thickness testing through flaw detectors, which I know a lot of people do, then it's really, really important to pick your calibration points very close to what you're trying to measure. I hope you found this video useful. If you did, please hit the like and subscribe buttons, and thanks for watching.